We always say we should appreciate the little things, right? Like clean air, for example. It's one
Yeah.
of those things you don't really think about
You don't think about it until it's gone.
until it's gone. Exactly.
Yeah.
Especially, if you're working in a tough environment,
Right.
say like hundreds of feet underground in a coal mine.
Oh, yeah.
Today's deep dive takes us into that world.
Okay.
We're going to be looking at some cutting-edge research on dust control.
Interesting.
Specifically, a paper titled Experimental Study on the Dust Control Performance of a Rotating Fog Curtain Under the Perturbation of Long Pressure and Short Pumping Ventilation.
Yeah, a bit of a mouthful.
Bit of a mouthful, I know.
But the technology they're exploring here, this pneumatic vortex fog curtain, is really interesting.
Okay, so before we get into the specifics, can you paint a picture for our listener of what kind of dust problem we're dealing with here? Why is this research so important?
Well, imagine you're in a coal mine,
Okay.
a tunneling phase, right? It's a really tight space. You've got massive machinery, breaking up rock,
Yeah.
sending clouds of dust particles just into the air everywhere. And it's not just any dust, it's coal dust, which poses some pretty serious health risks.
Right, because it's not like, sweeping up dust bunnies at home. This is industrial grade dust. And I'm guessing inhaling it day after day, not great for your health.
No.
So.
We're talking about really fine particles called respirable dust, and these can actually lodge deep in the lungs, leading to a range of, respiratory illnesses over time. And that's where this research comes in.
So what are they doing differently to tackle this problem? How does this fog curtain thing actually work?
So mines already use ventilation systems and water sprays to kind of control the dust, but this research is exploring a whole new approach. It's a device that essentially creates like a swirling wall of mist to trap those dust particles.
Okay, I'm intrigued. So they're basically building like a mini tornado of mist to fight off the dust? That's pretty ingenious.
It is.
Yeah.
And they used both computer simulations and real-world experiments to kind of test how well this works. They even built a scaled-down model of a mine tunnel to see how the fog curtain performed under different conditions.
Okay, I'm hooked. Give our listener the headline. Did it actually work? How effective was this thing at reducing dust?
The results were pretty remarkable.
Okay.
On average, this rotating fog curtain was able to reduce the concentration of respirable dust by over 90%.
Wow, 90%. That's a huge improvement. I can see why this is considered cutting edge. But I'm guessing it wasn't all smooth sailing. What were some of the challenges that the researchers encountered?
I think one of the biggest hurdles was figuring out how to integrate this fog curtain with the mine's existing ventilation system.
Right.
You can't just have this wall of mist just fighting against the airflow that's needed to keep the mine safe.
Right. Yeah, I can see how that would be tricky. Did they manage to find a way to make it work, or was the ventilation a deal breaker?
It definitely created some complications. Their simulations and experiments show that, yeah, strong ventilation airflow could disrupt the fog curtain, making it less effective. But even with that challenge, the fog curtain was still able to significantly reduce dust levels.
That's reassuring. It means it's not a fragile system. It can kind of hold its own, even in a real-world mine environment. Were there any other practical concerns that they had to address? Like, how much water does a system like this use that's gotta be a factor in a mine?
That's a good question. You'd think it would be a water hog, right?
Yeah.
But surprisingly, the research actually found that its water consumption was comparable to traditional spray systems.
So it's efficient, too. That's a big plus. Okay, I'm ready to get into the nitty-gritty of how this thing actually works. Walk us through the mechanics of this pneumatic vortex fog curtain.
All right, picture a circular device, kind of like a high-tech shower head.
Okay.
It's got these nozzles strategically placed all around it, and a high-pressure air is pumped into the device. And as it flows through, it creates this powerful vortex, much like a mini tornado.
Okay, so that explains the vortex part, but where does the fog come in?
That's where the water comes in.
Okay.
It's injected into that swirling airstream,
Uh-huh.
and the high-speed air atomizes the water, breaking it up into these incredibly fine droplets, creating that mist.
So it's not just spraying water, it's creating a super fine mist. What's the advantage of that?
These tiny droplets have a much larger surface area
Yeah.
compared to larger water droplets, which allows them to capture those dust particles much more efficiently.
Interesting. So it's like a dust-catching net made of mist, and then the swirling vortex pushes this mist outward, creating that wall-like effect we talked about, right?
Exactly. And because the mist is constantly rotating, it covers a much wider area,
Mm.
making it even harder for those dust particles to escape.
I'm curious, where would they actually install this system in a mine tunnel? Wouldn't it get in the way of like the mining operations?
Well, they envisioned mounting it near the source of the dust,
Okay.
like right by the coal cutting machinery.
Okay.
And it wouldn't really interfere because the fog curtain is not, it's not a solid barrier. It's permeable. It's a curtain of mist.
Yeah.
So the machinery can still operate,
Yeah.
but that dust gets trapped.
Now that you mentioned coal cutting machinery, it just makes me think about like the potential health implications here, right?
Yeah.
Like reducing dust by 90% could significantly impact miners' long-term health, I would imagine.
Oh, yeah. You're right. That reduction could mean fewer cases of black lung disease, other respiratory problems. It's a significant potential benefit for those working in these kind of harsh environments.
Okay, back to the fog curtain itself. You mentioned it's mounted near the machinery. Did they run into any like challenges with the actual installation?
One thing they emphasized was the importance of getting the angle of the nozzles just right.
Ooh.
That angle actually affects the direction and the force of that swirling mist. So if it's off, the mist might, dissipate too quickly,
Right.
or it might not create a wide enough curtain.
It sounds like they have to fine-tune a lot of parameters here,
Yeah.
from nozzle angles to air pressure and water flow rate to make this system work effectively. Did they ever test this, like on a full scale in a real mine?
So this particular research was focused on the smaller scale experiments and simulations,
Okay.
but the results were promising enough
Yeah.
to warrant, further investigation, possibly even real world testing.
It definitely sounds like they've laid a solid foundation. Beyond mines, did they mention any other potential applications for this technology?
Oh, absolutely. They briefly discussed the possibility of adapting it for other dusty environments like, construction sites, factories,
Right.
or even for controlling, outdoor air pollution.
Oh, wow.
It has the potential to improve air quality in a variety of settings. Imagine using this to reduce dust during a demolition project, or even to create cleaner air around, busy roadways.
Okay, that's fascinating. We've talked a lot about how it works, but let's circle back to the research itself. How did they actually measure the effectiveness of this fog curtain? What were they looking at?
They actually used two methods.
Okay.
For a quick assessment of the dust concentration in the air, they used what's called a direct reading dust meter.
Okay.
But then for a more detailed analysis, they utilized a dust sampler.
I'm assuming the dust sampler gives a more accurate picture of what's in the air. Walk us through that process. How does that work?
So it basically draws in a specific volume of air over a set period,
Okay.
passing it through a filter,
Uh-huh.
and any dust particles in that air get trapped on that filter, allowing them to measure the mass of dust collected.
Got it.
So they weigh the filter before and after sampling,
Uh-huh.
and that gives them the dust concentration.
It sounds like a high-tech vacuum cleaner for dust,
Yeah,
meticulously collecting and measuring every single particle.
that's a great way to put it. And they did this under various conditions. They measured dust levels with no control measures. Then they activated the fog curtain and measured again. That's how they determined that 90% reduction in respirable dust.
Of course, they also had to see how the fog curtain performed when challenged by the mine's ventilation system, right? So
Yeah.
how did they simulate that?
They simulated those airflow conditions you'd find in a real mine
Yeah.
by cranking up the ventilation system.
Okay.
And then they measured the dust levels, both with and without the fog curtain. It was kind of the ultimate test to see if it could hold up against those powerful air currents.
So what did they find? Did the ventilation like throw a wrench in the whole thing?
The results were quite interesting.
Okay.
While the strong airflow did disrupt the fog curtain, making it slightly less effective, it still managed to significantly reduce dust levels compared to having no dust control at all.
It's great that even when challenged, it still makes a significant difference. It speaks to the resilience of this technology. After all, you can't just turn off the ventilation in a mine. It's crucial for safety, right?
Exactly. It's all about finding that right balance between effective dust control and, maintaining a safe working environment.
Yeah.
And this research really shows the potential of the pneumatic Vortex fog curtain in achieving that balance.
This has been a fascinating look at a really innovative approach to an age-old problem. What's the key takeaway you want our listener to walk away with today?
I think the biggest takeaway is that there's always room for innovation, even for challenges as old as dust in mines. This rotating fog curtain technology shows how, creative solutions can protect workers and create these healthier work environments.
And, who knows? Maybe someday we'll see this technology used in all sorts of places to combat dust and air pollution. It's exciting to think about the possibilities.
It really is. And that's the beauty of, scientific exploration and discovery. Often, a simple idea, like a swirling wall of mist, can spark a whole new way of thinking.
Well said. And for our listener, if you'd like to delve deeper into the specifics of this research, we'll include a link to the full paper in the show notes. It's a fascinating read, even if you're not an engineer or a scientist.
And if you found this deep dive as intriguing as we did, be sure to share it with anyone interested in innovative solutions to real-world problems.
Because sometimes the solutions are swirling right in front of us, just waiting to be discovered. And on that note, we'll wrap up this deep dive. Thanks for joining us.
So they had this high-tech dust vacuum, but I imagine they didn't just, stick it in the tunnel and call it a day, right?
No, of course not. They really wanted to, compare these dust levels with and without the fog curtain running to get a real understanding of its effectiveness. So first, they measured the baseline dust levels, with no dust control measures in place at all.
So that gave them a starting point.
Right. Then they flipped the switch on the fog curtain and saw what happened.
Exactly. And that's where they saw that, really impressive 90% reduction in respirable dust.
Wow.
It clearly demonstrated that this fog curtain was doing its job, trapping those particles.
But then they really put it to the test. They wanted to see how it performed under pressure.
Yeah.
Literally with the mine's ventilation system going full blast.
Yeah, they simulated those real-world conditions where ventilation is just essential for safety.
Yeah.
And they found that, the strong airflow could disrupt the fog curtain a little bit, making it slightly less effective.
It wasn't a perfect solution.
Right.
It's interesting how there's this push and pull between different systems in the mine environment.
Yeah, it really highlights just the complexity of engineering solutions
Yeah.
in these types of environments. There's always a balance.
Yeah.
But even with the ventilation, it still significantly reduced those dust levels compared to having no dust control at all.
Which is a huge win for the miner's health.
Absolutely.
You can't just shut off the ventilation, so knowing that the system can still work effectively in those conditions, that's a big deal.
It is. It underscores, the potential of this technology to really improve worker safety.
Yeah.
Without compromising the overall mine environment.
Well, this has been a fascinating deep dive
Yeah.
into a technology that, honestly, I had never even heard of before. And it's kind of remarkable how something as simple as like a swirling wall of mist
Yeah.
can have such a significant impact.
It really speaks to the power of, creative problem solving and innovative engineering.
Yeah.
Sometimes the solutions to our most pressing challenges, they're hiding in plain sight,
Yeah, I love that.
just waiting for us to uncover them.
It's a reminder that there's always something new to discover, and even seemingly small advancements can make a world of difference.
Absolutely. So for our listeners, if you want to explore the nuances of this research further, we'll of course include a link to the full paper in our show notes.
It's a great read. Even if you're not a scientist. Yeah.
And if you enjoyed this deep dive, spread the word. Share it with your friends, family, colleagues, anyone who might be interested. Who knows? Maybe it will even spark a new idea or invention.
Because sometimes the most groundbreaking solutions are the ones that we least expect.
And on that note, we'll wrap up this episode of The Deep Dive. Thanks for joining us.